Hi, this is Chris Schomburg, and today we're going to talk about Lab 1, Basic Electronic Circuits. And so in Lab 1, we're going to learn about a selector switch, we're going to learn about a push-button switch, we're going to also learn about how to actually hook up a buzzer and how to actually hook up a solenoid. And that's pretty much what we're going to look at today, but those are the basic circuits we're going to look at. Okay, so to start out with, we can look here. This is our schematic, or this is our assembly drawing for electrical assembly of how to get a push button switch to actually work with a lamp. Now, real quickly, I'm going to actually exit out of this. We're going to draw what a push button switch looks like if it's normally open or normally closed. So to do this, I'm actually using a tablet, and you can see that tablet right here. It's a tablet that then I can draw onto the diagram here. So we're going to do that in a second here. So the first thing that we're going to do is we're going to select our color, and I'm going to actually, for this one, it's on a red background, so I'm going to actually select something that's a little bit different color. Let's actually go with like a yellow or something like that. Now, it turns out a push button consists of a type of operation that really has more than one contact. So really what it does is the push button operator causes the contact to be either commonly open or commonly closed. So essentially, it's either all open or all closed. And so most push buttons have a set of normally open NO contacts or normally closed NC contacts. So similarly, like if we look right here, if we're actually looking and we're diving into this guy right here, what it looks like as a diagram is going to actually look something like this. Okay, and that is identical to that. That's what that drawing is. But there's actually two different situations. So one is IBPB, stands for push button, one push button, and this is the normally open. So normally we just say N dot O dot like that. Normally open. We could write that all out, and we could actually say that as NORMALLY, normally open contacts. Okay, so that's what we could actually do. Now, it's a little bit messy. Yeah, I think these circles are a little bit too close. So actually, if we're being really picky, which I think we should be when we're making our drawings, we want these to look like they're open, because this is actually the contacts. And see, this is an open circuit. So an open circuit, really, what that means is that basically you have, it's open to air. Technically, that's one way of opening circuits. Or it's such a high resistance that no current is going through. The impedance or resistance is so high that no current is actually flowing through. And so one way of doing that is just literally opening up to air, and that's actually how this is done. So this is the push button one, opening circuit to air. And I'm going to be a little bit more picky about how I draw this. Make it look a little bit nicer here. Okay, and I'm going to be picky about this one too, because it's a little bit silly. There we go. And we're going to go like this. That looks good. Okay, now the other set of situations is normally closed. And typically that's actually how you're going to see it written, is normally closed like this. And it looks something like this. And then the circles are on the other side, indicating that it's actually touching, like that. And this is 1PB, which is push button. Okay, so that's another way of indicating it. And again, this is the same thing as saying normally closed. And then this is contacts. Okay, we can see that the contacts right here are actually touching. We can see that there's actually a it's actually the push button is then in a state of actually touching. And that means that there is current flowing through here. This means that the resistance is 0. There's almost no resistance here, and it is a short circuit. So it's basically like a jumper. Okay, so this is, and I'm going to say this is, can be N.O or N.C. Okay, so that's the two positions that we can have. Now, really, let's go ahead and let's say that this is, so if we have our electron flow, and I'm going to make the electrons black. So if we have electron flow right here, right there, and if we have this case, this is case 1, then this is an open circuit, and that's actually where the electrons stop. Okay, and so we have it open. And so this light is not on. Therefore, light is not on. Is in the off state. Okay, now I'm going to actually make this a little bit different. So in this case, I'm going to make the electrons red. And so in this case, we go like this. This is the electron flow. Now this case, this is case 2. And in this case, the electrons are going to flow through here, flow through here, flow through here, flow through here. And then we have a complete circuit. Okay, and I'm going to erase, this will erase the whole line, but that's okay. Okay, so that is basically a current loop. So what we have here is, this is case 2, we have a closed. And in this case, therefore, the LED, the light, is on. Okay, so in this case, we're actually going to see a lamp be on. And in this case, the lamp is off. Okay, so I'm going to just summarize here with green. So we have our case 1, the lamp is off, and then we're going to go with dark green right here. And this one, this is case 2. And that's the two situations that we have here. And really, this one right here, this is case 1. I should color coordinate it properly. Okay, so let's actually do the same colors. So let's go right here. Okay, this is case 1. And then this one right here, if we color code this properly, is case 2. There we go. And so that is our first circuit. That's our push button circuit. And we're going to actually show you the application of that in a little bit here.